And here we are. Okay, so we can't clear the screen, I just have to use this scroll thing here. It's convenient when you're scrolling to tear it off like this and then tear it off. I am not going to tear it off because one of the things we'll do today is somebody can pay me $10, I'll ship you the printout of the listing at the end of the session. I'll put it up on my Etsy store or something like that. So let's talk about what we're going to do. Here's this to-do list. Let me do that printout again. I'm going to use head to print the first 10 lines of the to-do list. First on the list is to learn head. Head is the standard editor. A bit more of the text that we're looking at. So I'm not going to cheat, unless I really have to. I'm not going to cheat during this session. I'm just going to use the standard editor. The standard editor is a line editor called Ed that's been around almost as long as this machine has. Since sometime in the 70s. And it lets you do things without a screen, which is part of the goal here. So the project we'll use for Ed is we'll write a chatbot. I want to have Twitch chat so that when somebody types into the chat, then we'll see it come up on the printer. And ideally we should be able to also reply here and send chat messages, but I think I'd love to have something that just subscribes and prints them out here. So there's this GitHub project called Chat Samples. I'm going to go clone that onto the Raspberry Pi that's running out in the distance here. I'm going to clone that project under my home directory. And one of the biggest problems with this machine is there's no copy and paste. You can't just like select this and paste it. So let's just try typing it. Oh no! That didn't work. Let's try again. I don't know, there's some glitch in the system. Yay, that works. I can clone the repository if I just end up typing it right. So here we are. This is taking forever. Let's see why, I wonder. It should be a fairly small repo. Now the Raspberry Pi, the host machine we're connected to, is really underpowered. So if things take a while, it's just because the computer is super slow. Let me see. have a layout over here. Right. You can see that there's this already, and it's cloning into the repo. Here and SSH into the same machine. So we don't need that. Pretty slow. 96%. And 100%. Okay. Isn't it fun? We could interrupt it, but then the whole program would stop and I'd lose my repo, so I'm not going to interrupt it. I'll just leave this thing to tinker away, and eventually we'll have a clone of the repository, and then we'll go edit some code. Once we have some code on the machine, then we can run Python, we can do all sorts of stuff. So the project here is to create a switch box, and I'm cloning a repository called the cat samples, which is just a fork of the Twitch API samples. So I'm going to try something here and see if this works. Control I. Sure enough, there's no tab key on the keyboard. There's an escape key up here. There's a control key. There's no tab. Control I is the tab character, and tab completion works just the way you would expect. And I'm going to use the Python version. Of whatever's in here. There's a chatbot, so let's see if we can edit the chatbot. Okay, 95 lines. I'll print that out in a minute. Let's describe a little of what we're doing here. This is a Teletype ASR33 terminal. It was made in about 1970. It is a computer terminal. It has a keyboard. It has a print. Before there was a graphical display or a CRT display, this was the most economical thing to use to connect to computers. The machinery is almost entirely mechanical. I have the lid on, I have all the cover on, so we're not going to see much of the mechanics today. Some of the time we'll show that. Down in the corner here is a tape punch that I can turn on and turn off. And I can pull tape. This is 1 inch wide paper tape. And there's also a tape reader, so that if I have a punch tape, then I can carry it to somebody else's machine and read it in. Punch tape was the early storage mechanism, so let me show you how that works. You simply turn it on and say, let's chatbot.high. You can see that this is echoing already on the paper tape. And then on the tape, this is the ASCII code for the chatbot that's printing out right now. The paper tape is just a copy. It's just literally a copy of the bits. I think which way around the bits work. I think this is the high bit, and this is the low bit. In other words, these are the most significant bits, and these are the least significant bits. And if you read across here, you'll see there's 4 bits and then 4 more, and that's how the data comes through. We're on a 7-bit system here, so the 8th bit is not punched. There's nothing coming out on the 8th bit. Well, let's leave it running. We'll end up with a lot of tape at the end of the day. That's okay. What I'm more interested in is this Python code that we're about to edit. Some interesting things about this Python code. There's no underscore on this machine, so we have a back arrow instead of an underscore where it says just in it. I'm going to close this, way too noisy. There's no underscore on this machine. The version of ASCII that this machine is based on is ASCII 1963, and that predates the underscore getting into the character set. There's also no vertical bar, there's no curly braces, and when we start working with code of any sort, not having curly braces may be a little bit of a limitation. We'll work around it. So clearly having a printout of the Twitch box is going to be really awesome. Editing it, well, we'll see. I may have to mark it up with a pencil. Let me go find a pencil, and you can watch the stream as it happens, and I'll come back in a second with a pencil. Everybody who's watching. It's nice to have a few people on this little silly little project of mine. Now we did a word count on this. It's 95 characters, 95 lines, so we shouldn't be too long before it all gets printed. I love it when there's typos in open source software in the comments, because it's like I'm gonna send in a PR to fix this one. But I want to add a new command in here. I want to add a command to beep the bell. I think that's the very first thing. And then when we run the bot, hopefully it'll beep the bell on the machine. And then if you are watching, you'll be able to just type ding and have the bell come out. Unfortunately, the lines are only 72 characters wide. We have less margin down here that you can't really see very well. 72 character right margin, and there's no word wrap by default. So I've implemented word wrap in firmware. I'll talk a little bit more about how this thing's connected together. There is a word wrap option that you can turn on here, the way that I've built this thing. But there's no word wrap in the mechanical Teletype terminal. So we have to be a little careful just to not hammer it into the edge of the paper. And if we want to edit a line that's more than 72 characters long, it can get a bit tricky. We'll see how we do that, if we get that far. I think I have all that domain, so we'll just go where it takes us. Now, several things to say about this. I'm going to wait until it stops printing, and then I'll have several things to say about this. Okay. All right. We have printed out this Python code that I just cloned. I had the tape punch turned on, so we have a listing of this thing on paper tape. There is no take-up wheel for this thing. I'll have to just wind it up in a spool. I'm going to keep this running. I have 100 feet of tape here, so a little bit more is not a problem. But I should explain some mechanicals for this system. Right. This is 1 inch wide paper tape, and there are 8 bits in a word or in a character, and the bits are punched across the way. So as it comes out of the machine, you have 8 punch rods that are operated by a solenoid that come and punch holes in the paper. So it's an 8-bit machine. It uses the ASCII character set, and so the high bit of the ASCII character set, this is just uppercase. It's effectively a 7-bit ASCII, and even the 7th bit is not very much used. There's not even lowercase and uppercase on this physical terminal. One of the things, if you notice on the printout, is everything looks like it's uppercase. If you actually go out to the Git repo and read the code, of course, it's Python, it's lowercase. There's a translation going on between the machine and the computer, and there's another translation going on between, basically the computer sends a message here, and the only thing it can print is uppercase, so it converts automatically just by dropping the bit. But on the way from the keyboard to the computer, there's actually a teensy microprocessor that's acting as kind of the terminal adapter, the terminal driver, and there's a big write-up on the GitHub. You can go read kind of all about that and look at the code of it. Basically, there are a few things that modern Linux doesn't do that old Linux is used to do, and handling uppercase-only terminals is one of them, so I had to put that in firmware. But then, having added some firmware, I'm going to do all sorts of other things with it. Let's see, where are we? Yeah, let's rewind. Some more things about this terminal. Okay, of course it's paper. That is nice because you can scroll back and see anything you like. You just pick up the paper. Alright, here's my to-do list. I'm going to learn Ed, and I'm going to use Ed to build a Twitch chatbot. And so I've cloned this Git repository, and the command that I want to implement is a bell command. So I chose this piece of Python because it looked like I could use this. I have not installed the IRC pip library, so right now, what was that file called? Chatbot. If I try run it, then I get this horrible stack trace. And it's probably, I hope it's not failing with a network issue, but I expect it to... Oh no. I'm using Cayenne for my Python. Oh no. Alright, back in a bit. I'm going to SSH into this machine and install 2715 in the meantime so that you don't need to deal with the noise of it. Okay, this chatbot does not work on Python 3. As you can see from the print command, we need parentheses here. So we're in Python 2 territory. Okay, we'll just deal with it. While Python is installing, and I'll show you. Actually, I'll switch to that so you can see it. Python is installing just SSH into the machine for convenience. But while Python is installing, let's see what else we need to do with this. We've got a main. These are underscore characters, and they just print as a back arrow because the underscore is not in the character set yet. I have a token, but I want to set this in the environment. I don't want to tell you guys my token, so we'll see how that goes. And I want to edit this file and add a new command, and the new command is going to be bell or ding or something like that. We'll just assume that the rest of it works. So it turns out Twitch has the Twitch chat is just IRC, so we can use the regular Python IRC library to access Twitch chat. Okay, Python is still installing. How much does the confetti holder hold? Great question. All right. Now, underneath of here, underneath the punch, there is a Chad box, and that is a Chad box full of Chad. I'll put it on the close-up so you can see it. That is a Chad box, and the Chad are all the bits. Each of these bits is literally a bit that was punched out from the punch tape, and this is today's load essentially, so it'll hold quite a lot. I have to be very careful to fix it back in place because this stuff is sticky, and if I accidentally end up with Chad bits all over the floor, it'll be kind of nasty. That is a lot of Chad that can go in the box, yes. It's sticky because this tape is oiled. One of the things about a mechanical machine is there's literally almost no electronics in this thing. Let me describe the circuitry a little. It's a serial terminal, and so it's 8 bits as we saw from the tape. It's a ASCII system, and the 8 bits you can maybe see inside of here are also the print head is driven by 8 parallel bars that then lift it to rotate this into position. So inside of here there is a mechanical parallel to serial converter. Oh yeah, I think the chat box holds a megabyte. So this thing, right? Each of these is 1 byte, and we've got about 10 bytes per inch. And I worked this out. A megabyte is quite long. A kilobyte is 1,000 inches, which is a pretty long way. Yeah, a megabyte goes a long way on this thing. A 200-foot roll of punch tape is a few hundred K. You could maybe store an MP3 of a short song on here if you really tried. So let's see, where was I? Yeah, okay. So there's a parallel to serial converter because it has a serial interface to the computer. And the parallel to serial converter is literally a distributor that rotates. Let me bring up a web browser. I'll show you some pictures of this. I'm not going to take the lid off today, but I have some pictures up on GitHub, so we can go look at some pictures. May take a while for me to find this. Let's see. I've got to get used to this thing. All right. And okay. Do you see my browser? I don't see my browser, so let's add it again. And Windows. run. And here's a web browser. Okay. Now, inside of this web browser, under pics, there's a whole ton of photos here, and some of these photos you will find have pictures of the innards of the machine and some sketches of my electronics and so on and so forth. Somewhere in here there is a photo of the distributor. I think I can show you this on Google Photos. Let's switch back to there for a second, check how Python is getting on. Oh my goodness. Twitch broadcasting really eats bandwidth. My internet has gotten all slow. So I hope this is not too laggy for everybody. Let me know if it's super laggy and I'll try to like optimize the bandwidth or something. Let's see how that goes. Alright. I'm going to switch back to this browser thing here. Now you see what I mean by super laggy. This is, I'll put the link in the chat. Actually, I'll put the link up in Twitter again somewhere. This is a selection of the photos that go with the machine, some of its innards while it was being restored, and there's a couple pictures here of the inside of this thing that you can see some of the machinery in action. Basically at the back here, on the inside of the machine, there's a rotating drive wheel, drive shaft, and the drive shaft drives this rotary encoder, and when it spins round, it's unlatched by the keyboard. It spins round and reads off the voltage level, or the current level, for each of the bits in turn and sends them down the line. So that's the parallel to serial converter, or the UART in modern terminology. Now let's see, do we have Python installed yet? We don't. Okay. Let's go. I can't edit any code yet. Python is still installing. Okay, a little bit more talk about the machinery of the machine that we're seeing. Oh no, it's 1 frame per second. Sorry about that. I'll see if I can improve that over time. So it's my first time really using this Twitch stuff, and my secondary camera is misbehaving a little. And the way it's misbehaving is that the secondary camera should give you a nice zoomed out cropped view, and it really doesn't seem to do that. I think maybe just because of bandwidth on my network or something. There we are. It's reset itself. Okay. Okay. Back to here. We can watch the progress of Python. The machinery is just a terminal, and there are these 4 parts to it. There's a printer and a punch, and on the input side there's a tape reader and a keyboard. And they all go in parallel. So then there are 2 circuits. There's a transmit circuit for the keyboard and the punch, just working in parallel. And there's a receive circuit for driving the printer and the tape punch. So if you turn on the tape punch, the printer is still going. You can't actually turn the printer off. Even if you're just punching a binary tape, then it still comes out on here. These then go to a current loop to USB converter that I built, and then that connects to a Raspberry Pi, which is my local machine. Of course, back in the day, this would connect to whatever big computer you had, And the reason for using current loop instead of voltage is that it's super efficient. It's very good at handling long distances. So you could have, yeah, thanks, good to see you, Annan. You could have this connected to a machine that's 10 miles away and it would still have reasonably good communication. Okay, I'm going to do a little recap of some of the projects that I've been working on so far before we get into this. Let's go to the home directory. And look at bin. And there's a variety of files in the bin directory with the useful things. What are you going to use this terminal for? Well, I'm going to use it to write code. I'm going to use it to do pretty much anything that you might want to do on a modern computer. But pattern here is an executable that I use to print patterns on the punch tape. And it's a little Python program that essentially reads little happy restrictions and you can find all of this on the GitHub. So let's try this. Now, do you see what it did? It printed out some skulls on punch tape. So there's all sorts of patterns you can run on this. Normally I'm not using this as the primary way to run this stuff because SSHing into the machine is so much easier. So I'll show you actually how I do that usually. And actually this shows up something interesting about Unix. I mean, if I SSH into this Raspberry Pi, then I've got two users connected, actually three users now, because I have the one that's running the Python install, and then I have the terminal that's connected here, and then I have my new account that I'm just logging in with. And so if I look at who's connected here, well, the GCC one, that's running a Python install, which will take a little while. My Raspberry Pi is ancient and severely underpowered. The third one, W, that's running W, that's me right here. What is it that makes the loud noise? The tape puncher or the printer? It's the printer. It's the print head. The print head is hit against the paper with this slightly inky now black rubber thing, and it physically hits the head against the paper. And then behind the paper is this platen, like a typewriter platen. It's kind of rubber coated, incredibly noisy. If you put the lid down like this, I think it's maybe half as loud as with the print head up. You can hear, even when it's idle actually, there's a motor that's running, but all the clutches are disengaged, so it's fairly quiet with the motor running. But when it's printing, the punch is negligible. You can't really tell whether it's on or off just by listening to it. It is kind of like a typewriter. It's actually a little like the IBM Selectric that again had this rotating head. It's unlike a normal kind of a mechanical hand typewriter in a couple dimensions. I mean, first of all, of course, it's driven by binary bits. Second, the platen doesn't move, the print head moves, and that's so that you can easily have continuous roll paper. The paper, you buy it on a continuous roll. You can actually buy new paper. This is brand new paper from Staples. It's not very good paper, but you can still get it. Yeah, and then this rotates rather than having separate keys directly connected to the keyboard. The keyboard is really not connected mechanically to the printer except through a latch, and the latch is so that that distributor I showed a little earlier, when I hold a key down, then the key is locked. The rest of the keyboard is locked until the key has been transmitted down the wire. And then once it's been transmitted by that rotating, a little lever gets tripped that unlatches the printer. That means I can go type the next character. So that's how the kind of the rate limiting keeps it not tip over itself. But that's the only mechanical linkage between the keyboard and the printer. Everything else is the keyboard sends wires, it sends current down the wire, and the computer at the other end echoes a series of bits down the wire that come out to the printer, and they can be completely independent. One of the fascinating things is you see exactly this on a Unix system. This separation between the input and the output, and standard in and standard out, really corresponds to the keyboard and tape reader and the tape punch. It is a proper teletype. Thanks, Luna. It is exactly a proper teletype. Now, teletype predates ASCII. There have been teletype machines since about 1900, thereabouts, and they ran the news. They were the news machines. They were the first digital communications machines working the telegraph. So you can trace the whole evolution back to the telegraph. But then, of course, once computers came along, you want something to connect to your computer to send it data, to get data in and out, and these teletype machines turned out to be incredibly convenient for that. This is the Model 33, which is kind of the cheap version. In the early 70s, no, in the kind of mid 60s, this was launched in 63. From like the mid 60s, when computers got more affordable, these things really took off because they cost less than $1,000, and so you could actually afford to have a teletype terminal and multiple terminals connected to whatever computer you had. And usually the computers, of course, previous to the mid 60s, had taken up a whole room and been million-dollar machines. But they started to decrease in price, and you saw these kind of departmental machines, things like the PDP-8 and the PDP-11 series from Digital, that were relatively affordable, that you could have a department with half a dozen people connected to them on terminals. And then, of course, the rest of computing history. Yeah, let me show you a little bit more on the terminal here. If I'm in Unix, then I just say hello. Sorry, if I'm not thinking, so if I say echo hello, then it just prints hello. Okay, so I'm on a pseudo terminal called PTS1, and so I can say echo hello to device PTS1, and it's exactly the same. I can also say echo hello to another device, and if you look at the top here, this teletype, physically, the teletype is running bash, and it's connected to a device called TTY ACM0. And if I say echo hello, then it comes out on the paper. It comes out on the punch tape as well. So usually what I do is like this. From some other terminal system connected to the same computer, and I want to print some skulls on punch tape, then let's run that Python code and send the skulls to the terminal to that PCY. And we get some skulls on punch tape. Skulls are beautiful. Skulls are so beautiful. And I love all the other things you can do with it too. I have Space Invaders, random patterns, all of these, various ribbons. Let's see if I can get one of these to misbehave. There are lots of interesting things to be learned about ASCII along the way. This is a ribbon that was actually developed by a guy called Eric, who's on Twitter. I'm going to push some nulls so that we can see more of this tape. So this is actually printing correctly. It's a little bit odd because I've got kind of 9 positions across the tape, and I've only got 8 bits in the byte, and my pattern doesn't take account of that, so I should change my pattern. I should fix my pattern to do that properly. If you look on Eric's Twitter, he does this nicely. He does it really, really well. I haven't printed this version before, so it turns out I didn't do it right. But listen up, because this character here, let's see, if we look at the bits across the way, this character here is binary. Let's see, the bell is character 7, and character 7 is the bell which will ring the bell. So let's try that. Let's print character 7 to the Teletype from another terminal, and it rings the bell. So this is the goal of my Twitch bot, is to ring the bell. So let's do that again from here. Python -c print chr7. Oh no, I didn't do that. Shit. Let's try that again. Oh no! Python's going to break with a horrible... There we are, failure again. Listen up, it's going to ring the bell. Beautiful. The sound of bells. So, normally the bell is like, that's a holdover from typewriters, of course. As you get somewhere near the end of the line, then you would hope to remind you that you should hit new line. The bell's going to ring. There we are, the bell rings. But of course the bell is actually just another ASCII character. In modern terminals you'll hear it as a beep. Same thing. printf/a should work too. It absolutely should. Absolutely. And thanks Chronal, the patterns look great. I'm glad to Glad to hear you like them. So yeah, we'll send some bell characters to the printer when we get to write a Twitch bot. So I'm leaving the punching on here. You can see these spaces, and actually the line discipline is sending some nulls to get the timing right. Getting the timing right for the serial interface to make it reliable has been a project itself, and I don't think I'm really done with it. It's reliable enough, it kind of works, but it doesn't, it's not purely clean. Anyway, look at the Teensy code if you're interested. We'll come edit that someday. So yeah, these are the spaces, and then you can see that it's inserting some nulls. The other place that we're inserting nulls is between a line feed and a carriage return, and that's for mechanical reasons. So if I hit carriage return, it returns the carriage. The carriage here has a dash pot on the end of it, and this has a little, has a rubber dash, and there's a cup that it slams into that damps it so that it doesn't run off the end into the table. The carriage return unlatches this little thing down here, and it will go zoop, but it just returns me to the beginning of the line. Line feed is the vertical motion. I can see this better actually if I put it onto local. Line feed, let's put some spaces out. Line feed feeds vertically, and return returns the carriage. And line feed and carriage return are different things. I have my Unix system set up so that I hit line feed and it expects a Unix line feed, as you would hope. Some systems are set up to expect a carriage return, and it just varies depending on the system. There's a Prime machine running an old version of Primos, another New England mini computer company, and that seems to take a carriage return as their entry point. Some more interesting things across the keyboard. There's no @ sign here, it's over here. There's this backward arrow, which is actually the underscore. In modern ASCII it's the same code point, but there is no underscore on this keyboard and print wheel. The characters code for that is the back arrow, and then there's an up arrow, and the up arrow is nowadays the caret, the hat symbol. Again, it prints as an up arrow because this is 1963 version of ASCII. There is a rub out character, and rub out doesn't display as anything useful, and actually it's not showing anything nice on here. Let's turn this off. This is what rub out really looks like. My Unix echoing is making rub out behave slightly odd, but let's get this into view. Here we are. This is rub out, and the rub out character is character 255, I guess, FF in hex, and it's called rub out because you could punch something on the tape, and then punch rub out over it, rewind the tape, and it'll rub it out. So that's the rub out character here. There's a repeat character or a repeat key, so in theory if I hit a letter and hold repeat down, it just repeats it. That's mechanical, so it just keeps repeating it based on a latch that hits the keyboard. Then there's a break key, and I'm going to talk about the break key some other time, but I'm not going to press it right now. Escape, Control, Shift. And then the most interesting key on the keyboard, I think, is the Here Is key. And the Here Is key doesn't do anything in this setup. It means send my station ID. And if I had if I had a teletype that was connected without a computer to some other teletype, and that's essentially the telex network that is still operational, I think, but before there were computers connecting everything together, you can literally connect these things on a loop and have as many teletypes as you like. And if I type something here, and it's connected to the print loop of another teletype machine, it'll come straight out on that machine. But when you do that, identifying which terminal you're talking from can be a little problematic. So they built in a hardware ID called the here is. And where I say hardware, it's actually in back of here there's a little rotating thing, and you can physically break off little pins and turn them into characters to encode your station ID. So if I wanted to call this ASR33, then I'd actually have to figure out which keys, which pins that corresponds to, and go break them off. So the here is key sends that sequence of up to 10 characters, or up to 20, I forget, down the line. And there's an ASCII code, I think, Control E, the identification key, that is the incoming version that will trigger here is. In this machine it doesn't actually trigger it, it's not wired up that way. But in some teletypes, if you receive the Control E character, it'll trip this answer back circuit and send your station ID down the line to whoever's listening. So again, that dates back to the days of before there was really computers connecting things. So my Python installer is really taking its time here. If I'd realized my chatbot was going to use Python 2, I might have prepared for it. So I wonder, could we get away with actually editing this in Python 3? It's using IRC, it's using requests, that's straightforward enough. The client ID, all of this looks fairly straightforward. There was a print statement that was breaking things, but yeah, print. How about I just edit this and put some parentheses around it. There's one print statement here. There's a print statement here with parentheses already. Yay! Yeah, let's do some coding. Let's do some real coding. Pin this up here so I can read it when we need to refer to the code. Alright. Yeah, okay. So we have 3 lines that we need to go edit on this thing. Let's see if we can edit it with the edge editor. I've not used Ed for like maybe 30 years. I don't know, quite a long time, and I was never an expert to start with. So let's use Ed. It is notoriously terse. I printed out a cheat sheet so that if I get lost, I have my cheat sheet, we're going to need it. Okay, we're going to need it. So, is there a search command in ed? I don't know. Yes, there of course it is. And it found and brought me to the line that has this print on it. So can I append a line under here, or can I edit? I should be able to say, I should be able to replace. No, let me do just something like stupidly easy, because yeah, thanks Luna. I found the slash. What I want to do, I think, is just append a line here. And let's make it easy. Okay. Okay, how do I look at the next line? I go plus. Okay. I want to delete this line. Let's just yank it. Okay. Okay, let's have a look at this. 4667. What's the next line? Oh no, my yank didn't do what I expected. How do I delete? Can I just, like, delete? I can. Let's delete that line. And let's go to the next one. Here we are. Okay. Okay. And again, I'm going to append. So we wrote 3771 bytes. I've edited a few lines. Let's go quit and let's try run it. Okay. Oh yeah, sure. Yeah, that would help. So this may take a while. It's still running my Python installer in background, so we'll have to just deal with it. Yeah, pip is going to take a while. Okay. So it's not actually the terminal's fault that this is going to be really slow. It's my little Raspberry Pi. And my little Raspberry Pi, I put in the back here thinking I need a Unix machine to connect to. And I didn't realize that I'd want to do real computing on it. But of course now that I have real computing, I should go buy I should spend the $30 and get a faster model. Okay. This is marginally friendlier than the Git thing. Alright. While this is printing, I'm going to do some house clearing here. I do love this progress bar thing. It's a real sign of progress, but people expect the console to be so fast now. And my little video of showing Git pull seems to have hit a chord because so many people know Git. And here's a real terminal that we're actually going to use this thing with. So, oh, it's fun. Okay. I love that you guys watch this. I hope you're having as much fun as I am. This is extraordinary. Yeah, I'm glad you think so. This is real good. This is real good. So if you want me to send you like a roll of paper tape, I have a 50 feet of paper tape in a little roll, and I'll stick it in the mail. I'll just put it up on my Etsy store so you can buy it for $5 for a postage or whatever it costs. Maybe 10 to cover the postage. Anywhere in the world. It's kind of loud in this room. I don't know if you have your volume turned up. But around here, it's... luckily, nobody else is trying to use this room, and so I can get away with a bit of noise. This machine is upstairs in my house. It's kind of in the media room. It smells a little. It smells of oil. And when it's running, it's super loud. So don't do this at home unless you want like noise. But the noise is all the attraction. Okay. Am I downloading more ITER tools? All of the IRC dependencies. Oh my goodness. Let's watch it go. Today's paper tape. I'll stick it there for page teaching. Yes, we have IRC. Okay, let's try. I don't know if this is right, but no, that's not going to be right. Let's see if it gets halfway to running anyway. So I have a problem in actually executing this because I have a environment variable called Twitch token, which is my OAuth token. But Twitch token is in uppercase. And so that causes me a little bit of a consternation. And we'll see what happens. Username, client ID, token, channel. Okay. Okay. Let's try this instead. I just knocked up this little batch file. Let's see if this helps. I don't know if channel is ASR33. Certainly the client, the user is ASR33, and I don't know what the client ID is supposed to be. So let's try it and see. Okay. I am going to switch back to here so we can do this thing. And Python 2.7 is still installed. Oh no, I'm gonna have to debug this. Okay, I think I'm tired enough that it's, I'm gonna call it a day. Python 2.7 is still installing. I haven't gotten very far with this. So I'm just gonna sign off. I'm gonna take this here and turn the machine off. Blessed silence. Thank you everybody for watching. I'm going to come back again sometime during the week. I'll just post a note on Twitter. Hope you've had fun. I've had a lot of fun. I'm exhausted now, and I'll see you all soon.